Hello and welcome to another video of Wise Interactive Learning. In this video, we are going to go through your exercise 6.5 of applications of derivative and specifically the Maxima and Minima exercises. So, in the first question, we have f of x equals to 2x minus 1 whole squared plus 3. And we can go by using traditional methods like finding the first derivative test, second derivative test, and we are going to see that it is going to go and fail at the second derivative test for all these questions, right? So we have a different technique which we'll use and try to have a different objective of these questions, and we'll try to solve them by using simple common sense. So what the common sense I'm going to apply, you're just going to see right now. Okay, so 2x minus 1 whole squared. So do you know any number when it's squared it is negative? Well, in real sense it is not. If the numbers x is going to belong to the real numbers, it is never going to happen. So we can say that 2x minus 1 whole squared is always greater than or equals to 0. So this number can be 0 or it has to be a positive number. So if we add 3 on both the sides, so we get 2x minus 1 whole squared. If you add 3 on both sides, what do we have? The whole function is always greater than or equals to 3. So on the left hand side we have f of x greater than 3. So can we tell from just this 2 to 3 steps what is the minimum value of this function? Well, obviously we can. So it states that the minimum value is 3 for this function. Well, how did we say? Since the value is greater than or equals to 3, it means that the least possible value is going to be 3. But what about the maximum value? So if we take the minimum value as 3, what is going to be the maximum value and at what points, right? So if you draw this function, we can say that x is always going to belong to the real numbers, and since x is so usually in positive or negative any direction, this maximum value will never exist. Why? Even if you put infinitely huge number inside it, there is always going to be a number which is always greater than that. But at what exact point does this minimum value of 3 can be attained? So we have taken somewhere over here in the first step that 2x minus 1 is greater than or equals to 0. So if we equate it to 0, what do we get? We get that 2x minus 1 is 0, and then we have x equals to 1 upon 2. So at particularly x equals to 1 upon 2, we can say that the value of this function is minimum, which is the value is 3. So in this way we are going to, by a different approach, we are going to solve the first question, and then we'll move on to the second question till fifth question. So in this video is going to be pretty huge, or rather very big in terms of the time length, but you are going to learn it very thoroughly how can we use different techniques. So for the first question there are 4 sub questions and we are going to use the same technique throughout, right? So for the second question we just have to manipulate what is 9x square plus 12x plus 2. So your second question gives us f of x is equals to 9x square plus 12x plus 2. So well, we see that there is something happening over here in the first term. Can we say that this is square of something? Like if we take a, is it a square of a? So can we say that a can be 3x? So 9x square is nothing but square of 3x. So can we define 12x as 2ab, isn't it? So if we define that, we need to find out what is b, isn't it? So for that finding purpose, we can directly take the solution as f of x is equals to 9x squared plus 12x, and now we need to make that adjustment. So if we take 3x and if you equate it to 2ab and then we find out what is b, then you will get b as 2, and since 2 squared we need to add on to it, so we can add 4 over here. But in the original value we have only 2 in the constant term. So can we subtract 2 from this to make the equation equal, right? So these and these terms are equal, so we have virtually made no difference. So by this you get 3x plus 2 whole squared minus 2, and now you can say that we have converted this particular function in a such a way that we can use the formula of 3x plus 2 whole squared being greater than or equals to 0. Now if any number squared, if it is greater than or equals to 0, which means positive, can we say if we subtract 2 from both the sides, it is going to be the same term, isn't it? And by this we can clearly state that f of x is nothing but greater than minus 2. Now if this function is having the least value, or rather if this function says that the least value it has is minus 2, what is the value of x? We need to find out what is the value of x, right? So right now we have got that the minimum value is nothing but minus 2, but at x equals to what? So this is the question. And from the first step again over here, we can say that if we equate 3x plus 2 whole squared equals to 0, then you have x equals to minus 2 upon 3, and this particular turning point gives us the x equals to minus 2 upon 3. So if x is equals to minus 2 upon 3, so somewhere over here it is going to be minus 2 upon 3. So in this way you can state that the minimum value of this particular function is minus 2. And what is the maximum value? So for maximum value, since x belongs to the real number, this function is going to have infinitely huge linearly going or exponentially going higher values. So it will not have any specific higher value or maximum value. So we can say that this function does not have any maximum value. So maximum value does not exist. So for the third question, we can clearly see x minus 1 whole squared is always greater than or equal to 0, right? But this term is negative in our given function. So if we multiply the whole term by a negative minus 1, rather negative 1, we get x minus 1 whole squared, and since we have multiplied with a negative number, the sign changes and we have this function, right? And now if we add 10 on both sides, we get minus of x minus 1 whole squared plus 10 is going to be less than or equals to plus 10. And what does this tell us? It tells us that, well, the function is always going to be less than 10. So it tells us that the maximum value of this function is going to be plus 10, but at what x interception, right? So we have clearly said in the first step, x minus 1 greater than x minus 1 whole squared is going to be greater than or equals to 0. So if we equate that term to 0, then we are going to have the value as 10. So x minus 1 is going to be 0 and x is going to be 1. So if you look, what is the maximum value? The maximum value is going to be 10 at x equals to 1. So what is going to be the minimum value? So we can clearly say that since x belongs to R, minimum value does not exist. Since no matter what value you put in, there will be always a minimum value lower than that for this particular functions, since you can put anything as x equals to a hugely infinite number. So now we'll see the fourth question, and we are going to say it in a different way by just looking at the graph, right? And if you plug in the fourth question, so it says that g of x is equals to x cube plus 1, and most of us know that the g of x, or let's say y equals to x cube, is function something like this, and you can clearly see that this function has a turning point or a point of interception at x equals to 0. So for this function at x equals to 0, y is also 0, isn't it? But if you add 1 to this function, so if you add 1 to this function is going to get shifted by 1 unit, isn't it? So at x equals to, so this function, so this black function is going to be g of x which is x cube plus 1, right? Well, now if you can tell me, please understand that at x equals to 0, again x equals to 0, what is the value of g of x going to be? G of x is going to be 1. So particularly at this particular point we have the turning point. So now we have, just by looking at it, we know that this point is going to be 1. But is it the minimum or the maximum value, or is it just a turning or a point of inflection, right? And we need to do the first derivative test. We can clearly do the first derivative test, or we, just by looking at this, we can clearly tell that it is just a point of inflection and it is not a turning point, so it will not have a value which is minimum or maximum for this function. But just for the sake of doing, we'll start to do the first derivative test, which is g dash of x is going to be 3x squared, and if you equate it to 0, you get x equals to 0, right? So here is your x equals to 0 again. So if you take g double dash of x equals to 6x, then again if you put x equals to 0, you get g double dash of x as equals to 0, and it satisfies a specific condition over here, which is g dash of x equals to 0, which is also equals to 0 g double dash of x. And it says that you need to check this method by only first derivative test, where you plug in the values less than or equals to a little more or little less than x equals to 0. So what are the values which are closer to 0 but are not exactly 0? You can put it as x equals to minus 0.01, and you can also put it as on the front side you can put 0.01, and if you plug in those values, you can clearly see that this particular function is increasing over here on the right side. On the left side also this function is increasing function, since the height is getting increased. So in this way you can solve the first question. Now we are going to solve the second question. So if you have liked this video and if you have watched this video till now, please make sure that you subscribe to this channel and like this video. Now on to the second question. So in the first sub question over here is f of x is mod of x plus 2 minus 1 as clearly given, and we are simultaneously going to see second question, which is g of x, which is minus of mod of x plus 1 plus 3. So in the first question we can clearly say that mod of x plus 2 is always going to be a positive number, right? It has to be either positive or 0. So can we subtract 1 from this, from both the sides? So we can clearly see that x plus 2 plus minus 1 is always going to be greater than minus 1, and clearly from this you can say that the minimum value of this function, minimum value is going to be minus 1. At what point? Clearly you can say it is minus 2. So you just don't need to find out by solving. You can clearly see from the example over above that the mod of x plus 2 we have taken it as 0, and hence at x equals to minus 2, that mod term, which is x plus 2, this is going to be 0 only at x equals to minus 2. So this is basic understanding. By this time you must have catched up upon it, and there is no minimum value. Why? There is no maximum value. So no max value, since x belongs to R. So for growing R, the real numbers, we cannot define a higher limit for this function, hence there is no maximum value. Similarly, we can say that x plus 1 is of mod is always going to be greater than 0, but if you twist the signs of it, we get negative mod of x plus 1. This is always going to be less than 0, isn't it? And if you add 3 to it, negative mod of x plus 1 is going to be, if you add 3 to it, it is always going to be less than or equals to 3. So since it is less than or equals to 3, we can say that the maximum value of this function is going to be 3. At what point? At x equals to minus 1, since this particular term is going to be 0 at x equals to minus 1. Similarly, we don't have no minimum values, we don't have any minimum values since x belongs to R. So no matter how many higher numbers you just plug in into this whole minus of mod x plus 1 is going to be negative. In the third question, we have sine of 2x plus 5, and for the fourth question we have f of x is equals to mod of sine of 4x plus 3, and we are going to see this question simultaneously and we are going to understand how easily can we do it. So do we know that sine of theta will always be belonging to minus 1 to 1, so that's the range of sine theta, right? So similarly, sine of 2x, is it going to have the same range? Yes. So if we add 5 to all the terms, we can get minus 1 plus 5, so you have 4, and sine of 2x plus 5 is less than or equals to 1 plus 5, which is 6. So in the between you have sine of 2x plus 5, which is nothing but your h of x. So h of x is always greater than 4 and it is always less than or equals to 6. So can we say the minimum value of this function is going to be 4, and can we say what is the maximum value? So maximum value is going to be 6, and for this question you can directly plug in what is the x value just by putting in the minimum and maximum values, and you can directly find out what is the angle for it. So in this case 2x is necessarily an angle because it is terms of trigonometry, and in the fourth question we are going to see the same technique apparently to find out what is the minimum and maximum value. So since the whole term is in the mod, it is obvious that this term is going to be greater than 0, right? But the inside function can be negative, isn't it? And for that we can use the same technique over here of sine theta. So can we say sine 4x is lying between minus 1 and 1? It's very obvious, right? So if we add 3 to it, so if we add minus 1 plus 3, sine of 4x plus 3 to all the terms, we can say that this function is lying in between 2 and 4. So when all the values are in positive, it doesn't matter if the function has mod or it doesn't have. So it just means that this function has a minimum value of 2 and a maximum value of 4, and at what angle, you can directly plug in the values in the first equation over here and find what are the angles. Now for the fifth question we are going to see h of x is equals to x plus 1, where x specifically belongs to rounded brackets of minus 1 till 1, and it does implies that minus 1 and 1 are not included in this specific equation. The third question is very interesting and it takes us one step ahead, and in trying to solve this we'll try to understand what are the different techniques used in this. So the first question in third question, it is f of x and our beloved graph which is x squared, right? So if we get f dash of x by first derivative test, we can put it as 2x, and if we equate it to 0, you have x equals to 0. So we have a turning point over here which is x equals to 0, right? But if you take f double dash of x, you get value as 2, and if you equate it to 0, this test fails. So the second derivative test we have necessarily failed. So you have to go to finding by the answer by the first derivative test, right? So what is first derivative test tells us that there is only one point which is the turning point, which is nothing but 0. So after x is equals to 0, we have an increasing function, and before x equals to 0 we have a decreasing function. So clearly we can say that x equals to 0 is a point of local minima. So it clearly gave us the nature. Why? Because if x is equals to 0.01, then the function is increasing, and if x is equals to minus 0.01, then the function is decreasing, and these two conditions are enough to tell us that the x equals to 0 point is a local minima point. But in case of finding what is the local maxima, since x belongs to R, we cannot find the local maxima. So this particular function does not have the local maxima. Now, since it doesn't have a local maxima, it is not going to have a maximum value. So we can immediately tell that we can have a specific value which is the lowest value of this particular function at the local minima value, which is going to be f of x is going to be 0 squared, which is equals to 0. So this is your minimum value. Now we'll move on to the second question. So in second question we have g of x equals to x cube minus 3x. So second question we have g of x equals to x cube minus 3x, isn't it? So can we say g dash of x is equals to 3x squared minus 3? If you equate this particular function, we can get that to 0. We have 3 times x square minus 1 equals to 0, which means x minus 1 x plus 1 times 3 is equals to 0. So we have x, you have two turning points, which is minus 1 and 1. So g double dash of x, we can get 6x, right? Now when you put g double dash of minus 1, what do you have? It is minus 6, and when you have g double dash of 1, you have plus 6. So since minus 6 is less than 0, you have this as the maxima point, and since this is greater than 0, this is minima point. So immediately you have two turning points and their value are minus 1 and plus 1 for x equals to minus 1 and plus 1. And so now we can immediately find out what are the values. So the maximum value is going to be what? G of at that minus 1, which is going to be minus 1 cube times minus 3 times minus 1, which is going to be minus 1 plus 4, it is going to be plus 3, and minimum value is going to be g of 1, which is going to be 1 cube minus 3 times 1, which is going to be 1 minus 2, which is 1 minus 3, which is minus 2. So the third question h is h of x equals to sine of x plus cos of x, where x only belongs to greater than 0 and less than pi by 2, and you need to be very careful in this particular function. Okay, so can we say h dash of x is equals to cos of x minus sine of x, isn't it? And if we equate it to 0, we have sine of x is equals to cos of x, where we can say if we divide the whole term by cos of x, you get tan of x as equals to 1. So you have x equals to pi by 4. Now you have an angle. So x, you know, x is a turning point. Here it is an angle which is pi by 4. So immediately if you get h double dash of x, you have minus of sine x minus cos x, which can be also written as minus of sine of x plus cos of x. And now since you have pi by 4 as an angle which is a turning point, you can always put it over here. So if you put it, you get the value as minus of 1 upon root 2 plus minus 1 upon root 2. So which also is, since you get 2 in the numerator, minus root 2. So your h double dash of x is minus, or rather this number is less than 0. So you can say this value is a maxima point, right? So your maxima point is going to be nothing but pi by 4. So if you plug in the pi by 4 at h, your maximum value is going to be 1 upon root 2 plus 1 upon root 2 is going to be root 2. So this is your maximum value at pi by 4, and for this particular function we can say that since it is in the range of 0 to pi by 2, we need to find out what is the minimum value. So since we have only an inflection point of greater than 0 and less than pi by 2, we only have a maximum value for this particular function. Now we'll see the fifth question. So now we have a fifth question with us, which is f of x is equals to x cube minus 6x square plus 9x plus 15, and we need to immediately understand f dash of x is equals to 3x squared minus 12x plus 9. So immediately if we take 3 common, we have x square minus 4x plus 3, and if we equate this to 0, we are going to find out what is the answer. So we have x square minus 4x plus 3 equals to 0, and immediately we can say that this 4 is the product of two numbers and plus 3 is this sum. So by this we can say x square minus 3x minus x plus 3, and if we take x common over here, we have x minus 3, and minus 1 common over here, we have x minus 3. So your answer is x equals to 1 and 3. So you have two turning points which are 1 and 3. So immediately you can go on to the question and see there are two turning points, and in this case we are going to see what are those turning points, either maxima or minima by f double dash of x. So the f of x we have as 3x square minus 12x plus 9. So f double dash of x is going to be 6x minus 12. So in this case we have f double dash of 1 as equals to 6 minus 12, which is going to be negative 6, and f double dash of 3 as equals to 36 minus 12, which is going to be 24. So since this is less than 0, this is greater than 0, this particular point is going to have the maximum value, and this particular point is going to have the minimum value. And in this way, if you plug in the values, you can exactly find what is the value of that particular function, and that is going to be the maximum for x equals to 1, and it is going to be minimum for x equals to 3. So if we put f of 1 in the original function, we have 1 minus 6 plus 9 plus 15. So 9 plus 15 is 26. 26 plus 1 is 27, minus 6 is going to be 21. So 21 is your going to be maximum value, and in case of minimum value, f of 3 is going to be 3 cube, which is 27, minus 6x squared. So 6 times 9 is going to be 54, plus we have 9 times 3, which is 27, and then we have plus 15. So this is going to be 27 plus 27 is going to be 54, and 54, so these three terms are going to get cancelled, and your final answer is 15. So your lowest value is 15 at x equals to 3, and your maximum value is 21 at f equals to 1. So by this we have completed 3 questions, and you can solve the remaining questions by same technique, and you can solve all the answers. So in the next video I am going to explain question number 4 and question number 5 for exercise 6.5. so it's just going to be the continuation of this particular function exercises, and after that I am going to explain the word problems for maxima and minima.